Welcome back to our channel, where we explore the cutting-edge science and innovations combating aging and disease. In this video, we're delving into a groundbreaking and fascinating development in anti-aging and health enhancement, bioreactor-grown mitochondrial transplantation. This intriguing approach slows the aging process and potentially revolutionizes the treatment of age-related diseases by using bioreactors to grow healthy mitochondria for transplantation. We'll share about everything from the science behind mitochondrial aging and the technology enabling this innovation to the pioneering efforts of biotech startup Matrix Bio. We'll also share insights from the latest clinical trials and research, discussing the challenges, future directions, and how this could fundamentally alter our understanding and management of human health and aging. Stay tuned as we unwrap this new frontier. Are you curious about the promise of cutting-edge aging research to rejuvenate your health and vitality? Then commit to your well-being by tapping the like button and subscribing to our channel so you don't miss a thing. We are your portal to the secrets of longevity. Now let's dive in. Imagine a future where the sands of time could be slowed, where the whispers of aging are hushed to a murmur, allowing us to live vibrant until we reached 130 years. This isn't the plot of a science fiction novel, but the promise of bioreactor-grown mitochondrial transplantation. At the heart of this groundbreaking approach is the power to rejuvenate our cellular engines, the mitochondria, offering hope not just in the fight against aging, but in transforming how we understand and experience the human lifespan. Mitochondria are the tiny power plants inside our cells, working tirelessly to fuel our bodies with energy. They convert our food into adenosine triphosphate, ATP, a universal energy currency that powers every blink, breath, and thought. These microscopic energy factories are even more fascinating because they carry their own DNA, passed down almost exclusively from our mothers. Ensuring our mitochondria are happy and healthy is vital to our overall health, impacting our heart, brain, muscles, and more. When these cellular powerhouses aren't working correctly, it can lead to various health issues, from heart and brain problems to the challenges of aging. Keeping our mitochondria happy for an entire human lifespan is one thing, but to carry us for 130 years, we need revolutionary technological interventions on the horizon, like mitochondrial transplantation and bioreactor technology. Mitochondrial transplantation, a cutting-edge treatment, holds immense promise. It involves the transfer of healthy mitochondria into weakened or damaged cells, akin to infusing new life into ailing power generators. By introducing fresh, functioning mitochondria to struggling cells, this innovative therapy offers a beacon of hope. It aims to jumpstart the cell's energy production, paving the way for better health and recovery. Bioreactor technology, a sophisticated life-supporting environment, is a game-changer in mitochondrial growth. It allows us to cultivate and multiply mitochondria outside the human body. This innovative approach means we can produce ample, healthy mitochondria ready for healing purposes. Using bioreactors to boost mitochondrial growth is a solution to the tricky problem of finding enough healthy mitochondria for transplants. By maintaining the perfect settings for mitochondria to thrive and multiply, bioreactor technology ensures we have ample amounts of these cellular power units needed for medical treatments. Think of bioreactors as high-tech nurseries, critical for growing mitochondria on a large scale, making the dream of mitochondrial transplantation a reality. This is crucial because we need loads of healthy mitochondria to fight various diseases with mitochondrial transplantation. With bioreactors, we could grow enough of them, slowing down the potential spread of this exciting healing method. Thus, bioreactors are not just helpful, they are indispensable in bringing mitochondrial transplantation from the lab to the patient, ensuring we have enough healthy mitochondria to go around. Matrix Bio, pioneering bioreactor-grown mitochondrial transplantation. Matrix Bio, a groundbreaking biotech startup nestled in the vibrant community of Pleasanton, California, is poised to deliver on the promise of this cutting-edge technology. Through their pioneering method of nurturing healthy mitochondria in bioreactors and introducing them to patients, they strive to boost energy production and kickstart tissue regeneration. This groundbreaking work could flip the script on how we treat conditions rooted in mitochondrial dysfunction. Imagine the possibilities if projects like Matrix Bio's 18-month exploration and the intriguingly named the 130-year-old lifespan trials succeed in their ambitious goals. This trial is a groundbreaking project, aiming for a future where living to 130 but feeling like you're 50 becomes the new normal, calling on volunteers, particularly those in their golden years of the 70s and 80s. This trial sets the stage for them to break the record of the most extended human lifespan, currently set at 122 years old, by French supercentenarian Jean-Louis Calment. Conducted in the innovative Biotech Explorers division of Matrix Bio, the focus is on transplanting mitochondria grown in bioreactors. This treatment is rolling out first to a particular group, including astronauts and young participants battling premature aging diseases. Early tests on animals have hinted at the vast promise of this technique: quicker healing, more robust defense against infection, and yes, a longer life. These experiments and studies spotlight the game-changing potential of mitochondrial transplantation, especially from those cultivated in bioreactors, as a powerful ally against the tide of aging. Phase 1 trials are scheduled to start in late 2024. The potential of this breakthrough technology to transform the landscape of human health and aging is nothing short of staggering. At its core, cultivating mitochondria in bioreactors tackles a pressing issue: the limited availability of healthy mitochondria for transplantation. This leap forward paves the way for a broader application of mitochondrial transplantation, offering hope for combating a variety of conditions linked to mitochondrial malfunctions like Alzheimer's, vision loss, heart disease, and the physical decline often seen in older adults. By introducing a fresh supply of robust, lab-grown mitochondria into the body, we have the potential to alleviate the energy deficits and cell dysfunctions associated with aging. The impressive enhancements observed in animal studies, in terms of strength, mental sharpness, and outward appearance, vividly demonstrate the potential of mitochondrial transplantation to redefine our later years, making them healthier and more vibrant. The introduction of bioreactor technology in the cultivation of mitochondria could be a game-changer in the field of personalized medicine. Imagine the ability to custom-create these cellular powerhouses to target specific diseases, enhancing the efficacy of treatments like never before. Moreover, the potential to produce mitochondria in large quantities holds the promise of making groundbreaking therapies accessible to millions, transforming the way we approach global disease management. Nonetheless, tempering our excitement with a dose of realism is wise. These are the early days of this technology, and there's a lot we still have to learn. Yet as we move closer to unraveling the mysteries of aging, this innovative technology lights up a path to fighting the signs of aging and enhancing life's golden years for people everywhere. Bioreactor technology and transplantation technology have their challenges. Among the most pressing is figuring out how to get the mitochondria where they need to go, inside the targeted cells and tissues. While some current methods like direct injection or particular molecules that help mitochondria penetrate cells are promising, they aren't perfect. Another primary concern is how our body reacts to these foreign mitochondria. Using mitochondria from the patient's body tends to be safer and elicit a smaller immune response. However, using mitochondria from others in allogeneic transplantation raises the possibility of the body rejecting them. This area too is ripe for deeper exploration to find ways to reduce or avoid these immune responses. Ethical questions are at the heart of discussions, particularly regarding where donor mitochondria come from and the impact of transferring mitochondrial DNA on future generations. The conversation around whether we should view mitochondrial transplantation as similar to donating eggs or tissues highlights the necessity for in-depth ethical contemplation before even thinking about bringing this to patients. Looking ahead, the focus should shift towards refining the technology, understanding more deeply how our bodies might react, and tackling ethical dilemmas head-on. There's also room for innovation by combining mitochondrial transplantation with other treatments to slow aging. Investigating how mitochondrial transplantation could work hand-in-hand with different strategies to combat aging could open doors to groundbreaking therapies, focused on keeping us youthful and healthier for longer. Like any technology poised to radically extend lifespan, the successful application and deployment of bioreactor-grown mitochondrial transplantation has the potential to change healthcare and how we live our lives, intersecting with everything from the economy to ethics. Imagine a future where diseases linked to aging could be fixed by swapping out the faulty ones with healthy lab-grown versions. This advance could lighten the load on our healthcare systems significantly by reducing chronic illnesses and possibly cutting the costs tied to long-term care. Workplaces might see vigorous contributions from those traditionally considered past their prime, shifting how we view employment and retirement. Families might experience transformations too, as longer, healthier lives could change the roles and expectations of our elders. Yet with this groundbreaking shift comes a web of ethical questions. Who gets access to these treatments? How do we prevent a divide between those who can afford a new lease on life and those who can't? And what about our planet? Can it support a population that lives significantly longer? Thank you for watching our video. We hope you got a ton of value. You don't want to miss the groundbreaking discoveries happening in anti-aging research on an almost daily basis. You'll see them here first on our channel.